most exciting thing to happen last week was the announcement of TensorFlow.js, a JavaScript library that allows us to build, train, and make predictions from machine learning models directly in the browser. We'll use TensorFlow.js with Angular to take a hand-drawn digit image and then predict its actual numeric value. I'm super excited about this because it opens up a whole new world of possibilities to combine web development with machine learning. Make sure to subscribe if you're new here, and you can grab the source code from angularfirebase.com. The first thing we need to answer is, what is TensorFlow? And the simple answer is that it's a library for performing mathematical computations. But it's famous for building deep neural networks that power some of the most impressive artificial intelligence technology that we have in the world today. The sad part of this answer is that if you don't have a background in machine learning, TensorFlow is not going to be very easy to use or very useful to you. That being said, I started out with zero machine learning knowledge a couple years ago, and have worked my way up to an expert rank on Kaggle, which is the hub for data science competition around the world. If you want to get really good at machine learning, I recommend spending about half your time with traditional courses such as Coursera or Google's machine learning crash course, and spend the other half of your time applying what you learn in data science competitions on Kaggle. But be careful, because data science competitions can be very, very addicting. If you're watching this video with zero machine learning background, I still want to give you a high-level overview of how machine learning models work. The typical narrative goes something like this. We have a set of data, and each item in that data set has a label telling us what it is. In this video, we're using a data set called MNIST, which is a series of images of hand-drawn digits. Because you're most likely a human being, it's easy for you to recognize what these digits are. But to a computer, each image just looks like a matrix of values, and it has no way to discern the context or actual meaning of the image itself. A typical image recognition convolutional neural network is going to look at many samples of these images and attempt to extract features out that will distinguish one digit from another. The algorithm starts off completely random, then slowly corrects itself after seeing more and more samples of these images. So that's a very high-level overview of how a TensorFlow model might work. What I want to show you now is how we build and train a model and then make predictions from it in the browser. I'm going to generate a new Angular app with the Angular CLI, then we'll CD into the app and install TensorFlow.js. For this first part, what I want to do is show you how to build the most basic possible TensorFlow model, which would just be a linear regression. So we'll feed TensorFlow an array of values that should predict some other value. Think of the relationship between a person's height and weight. You should be able to use their height to roughly predict their weight. We will train the machine learning model in Angular when this component is initialized, and then when the user enters a new value into the form field, we'll run a new prediction with that TensorFlow model. If you're more of a visual person, the actual data set would look something like this, with the blue dots being our samples, and then the red line being the model that TensorFlow generates. Let's go ahead and code this up by opening the app component in Angular. Then we'll import TensorFlow under the namespace of TF. Then I'm setting up a property called linear model that defines the actual TensorFlow model that will train and make predictions. We're going to use the sequential API in TensorFlow.js, which is a little bit higher level and easier to work with. It's very similar to Keras if you have a Python background. Then I'll also set up a property for the prediction value so we can show it in the front-end UI. In this demo, we're only training some randomly generated static data, so we'll do that as soon as the component is initialized. TensorFlow.js works in promises, so it tends to be really easy to work with in JavaScript apps. We'll set up an asynchronous function here called trainNewModel. Then we'll define an empty model by just calling tfSequential. In this case, we're just performing a linear regression, and we can do that by adding a dense layer or a fully connected layer that will output a shape of 1 and also take an input with a shape 1. In larger neural networks, you have multiple layers, and the dense layer keeps all of the neurons in each layer connected together. But since we're only drawing a single straight line through the data, we don't really need to worry about that. We just need to define the loss metric, which in this case will be mean squared error. In other words, we're just trying to minimize the mean squared error of the predictions from the algorithm. Then we also define an optimizer, which is the function that determines how we reach this actual minimum error point. SGD stands for stochastic gradient descent, and there's a number of different optimizers that you can choose from. So that's actually our entire model right there. Now we just need to train it by feeding it some data. But we need to feed it that data in the form of a tensor. But you might be asking yourself, what the hell is a tensor? For our purposes, the easiest way to think about it is just as an array. For example, a one-dimensional tensor would look the same as an array of numbers. The actual tensor terminology is not something you really need to get tripped up with, especially when you're just learning TensorFlow. As you can see here, we have one tensor named xs. When you have a variable named x in machine learning, that means it's your actual training features for the dataset. The y variable, on the other hand, is the label for that data. It's the actual thing that we want our machine learning algorithm to predict. Depending on the size of the dataset, training the model can take a long time, but in this case we just have a few values, so it's going to happen very quick, and we make that happen by calling linear model fit with our x and y data. The end result there is that we have a statistical model that can now predict values based on this dataset that we've provided. To make a prediction, we'll call linear model predict, then pass in the value in the form of a tensor. That's going to return a prediction in the form of a tensor. So now we just need to convert that tensor into something that we can use in Angular. Everything in TensorFlow runs in the context of a session. So to get out the data we actually want, we create an array and then call data sync on the tensor. Now we'll switch over to our HTML and run this linear prediction method whenever the form value changes on this HTML form input. If we pull up the app in the browser, we should get the results of our linear regression. If you enter a smaller number, the prediction should decrease. If you enter a larger number, it should increase. Now that you know the basics, let's do something a little more complex. Neural networks have really revolutionized image recognition problems. In this example, we're going to take an image of a handwritten digit using an HTML canvas, and then we'll have our neural network predict what the actual value of that number is. The training process for an algorithm like this is way too CPU and memory intensive to run in the browser. But one of the really cool things about TensorFlow.js is that we can import models that have been trained in Python. So that means you can build your own machine learning model on your local system and then upload it to your web app so your users can use it on the web. I included my model in the source code for this project, but I recommend going to Kaggle and participating in the digit recognizer competition using Keras to build your own from scratch. Keras will allow you to export your trained model, and then TensorFlow has a tool that allows you to convert that model into a format that can be used specifically by TensorFlow.js. To install that tool, you need to install TensorFlow.js with the Python package manager pip. Then it gives you a command that will take the Keras file and not only convert it to TensorFlow.js, but it will also shard the file so you can load it efficiently on the web. For right now, I'm just using the assets directory in Angular, but you'd want to use a cloud storage bucket in the real world. Now that our model has been converted to TensorFlow, I'm going to go back into the app component and add a load model method to ng on init. And a quick side note, I'm using this drawable directive to create the HTML canvas. I'm not going to show you that code, but it's in the main repo if you want to check it out. You'll notice here that this time our model is typed to just a plain TensorFlow model. That's the lower level API that's generally a little more difficult to use if you're a newcomer. Then this time our predictions will be an array of 10 different values, where each value represents the probability that that index is the correct value for the drawing on the canvas. So we can take the index with the highest probability and assume that that's the number that was drawn on the canvas. Since our model is already pre-trained, we can just load it with a simple one-liner of TensorFlow load model. But our predict method is going to be a little more tricky. The first thing that makes it more tricky is that we need to think about memory management. Neural networks can use a lot of memory, and we want to avoid memory leaks in our client-side app. To do that, we can run all of our code inside this TensorFlow tidy method. That will ensure that all of our tensors are released from memory when the prediction is finished. The actual image data that we want is coming from the HTML canvas that we're extracting as the image data type. You can pass in a variety of different types here, and it will convert the image into a tensor that can be used in the TensorFlow graph. In our case, this model was trained with images that were 28 pixels by 28 pixels with just one color channel. So we need to reshape our data into that shape. The first value here is the batch size, which is going to be 1 because we just have one image, then 28 pixels by 28 pixels, and one color channel. The Python model that I trained for this demo is using an integer data type, but TensorFlow requires it to be a floating point. So we can change that by calling TensorFlow cast because all data types in a tensor need to be the same. So now that we have our data in the correct format, we can just pass it into our model and call predict. And just like last time, it returns the prediction as a tensor. So we'll convert that to an array and call data sync. In this demo, I've set up my app to run this predict method every time a new image is drawn into the canvas. It's not a perfect model, but it's about 90% accurate with my handwriting. And you can clone this repo to try it out for yourself. But if you're curious to visualize how the neural net works under the hood, I recommend going to the TensorFlow playground. This was actually the original inspiration to TensorFlow.js, and it shows you how neural networks build complex boundaries around datasets to make predictions. I'm going to go ahead and wrap things up there. If you want to see more TensorFlow content, please let me know in the comments. And if you want to learn how to build modern JavaScript apps for any platform, consider becoming a pro member at AngularFirebase.com. You'll get access to a huge library of exclusive content, as well as one-on-one project support. Thanks for watching, and I'll see you soon.